Hello and welcome to the first ever episode of CytoLED Interviews, where we'll be talking with top scientists and prominent figures in red light therapy research. Our guest today is Vladimir Heiskanen, a name that's synonymous with red light therapy research. If you're unaware, Vladimir has been covering red light therapy for years and has a fantastic research database that is definitely one of the top resources available if you're interested in red light therapy. We'll include a link to it in the description section. You'll also find our social media and website cytoled.com in the description, so please feel free to get in touch there with a comment or question about CytoLED or red light therapy, and we'll be more than happy to get back to you. Without further ado, here's the interview. Hello, Vlad. Could you introduce yourself and tell us how you first got interested in red light therapy?
I'm Vladimir Heiskanen, a dental student from University of Helsinki in Finland. And now I've been studying dentistry for 5 years, but even a couple of years before that, I used to read a lot of research related to medicine and nutrition and health. And I also started a health blog, which is nowadays quite popular in my country and followed by even like many professors and scientists. And at first, I read a lot of research about like diets and dietary supplements and drugs and lifestyle interventions, including like those targeting circadian rhythm and stuff like that. But then 6 years ago, I noticed that some people were writing about red light having effects on animals and humans and how the cells work. Especially like there were some people claiming that red light could improve the energy metabolism in cells. So I tried to find some evidence from that in PubMed, and surprisingly, there were a lot of studies on that topic. So that's how I originally got interested in this red light therapy, or as most researchers call it, photobiomodulation.
You're well known online for creating a database of red light therapy research. How did that come about?
Yeah, at first, when I looked at the research related to red light therapy, I noticed that there is like more than 50 different keywords for this one treatment. So if you use this search for the research articles, you could write low-level laser therapy or photobiomodulation or soft laser or light-emitting diode therapy or visible light irradiation. So it's kind of very clustered. If you want to find all of the papers about using red light for example, treating brain disease, you would have to use all these dozens of different keywords. So I was thinking that if I could make a spreadsheet, it would make this data search much more convenient. And in the beginning, I thought that there is actually something like maybe 2,000 papers on the topic. So I thought that if I spent 1 or 2 years on the project, it would be finished. But then, like nowadays, the database or the spreadsheet has more than 4,000 studies, and it was a really hard thing to finish, taking a lot of time. But that's how I ended up doing it. And nowadays, it's the best source for PBM research in the world, I think, because if you want to find any studies on any indication, then that's the clearly fastest resource for that.
Can you tell us a bit more about the database and where to find it?
The easiest way to find the database is to write the address, which is www.bit.com/pbm-database, and the PBM should be with capital letters. But I guess you can include the link in the description of this podcast. And basically, the database nowadays, it has 4 different tabs. The first one is the most important, and it has the collection of more than 4,000 studies about photobiomodulation or red light therapy research. And it's separated by categories. So, for example, if you are interested in applications of red light therapy in oral diseases or in dentistry, there is this oral category, and there is a separate category for pain, separate category for joints, separate category for mechanisms, and so on. And from there you can, for each study, the database also tells what was the journal that published it, when was the study published, where are the researchers from, and what are the main results. And there is some other information as well. Then in the database, there are some other tabs, like the one listing all of the ongoing trials that have been registered to this clinical trials database. There you can see that nowadays there are almost 150 studies that are being done all around the world with PBM devices. And then there is also a tab in this database that is about different websites related to the subject. Like there you can find links to blog articles and books and news stories and researcher interviews.
What do you consider your most promising findings that you discovered while looking through the research to make your database?
I think the most interesting thing is that there is so much research on PBM, and for example, if we look at the human data, there are more than 600 randomized studies, which is a pretty huge amount of clinical research done. If you look at for some other treatments or supplements, very few have been studied so intensively. And there were many meta findings like that. Approximately 70 different countries have published research related to this topic, and that there are something like 700 different medical journals that have published papers related to photobiomodulation. And there are a lot of high quality journals as well that have published research related to this topic. As before I started reading about photobiomodulation, I thought it's a topic that hasn't been studied a topic that most scientists would find not very plausible, but at least many papers have been published in very high impact journals like The Lancet or PNAS or circulation or blood or annals of neurology and such high impact journals. And one of the good news is also that each year more papers are being published. So this is kind of a hot topic in the scientific field right now.
And what do you consider the most promising area of red light therapy research?
One interesting thing is that there are like scientific fields called, for example, geroscience, which focuses on these findings that many age-related diseases have the same mechanisms. Like if you compare heart disease or diabetes or eye diseases or hair loss and many other things that are more common when you get old, these very different diseases have similar underlying mechanisms. And so far, it seems that red light therapy probably improves some basic mechanisms that are very common in many different chronic diseases. If we look at the animal studies, red light therapy has been beneficial for more than 100 different diseases, and in humans it has been investigated for dozens of different health problems. And there are some indications that are maybe a little bit more promising than the others. Nowadays, a lot of trials have been started that are targeted to some brain diseases. Especially in America, there are, for example, if we look at the Massachusetts General Hospital, they have started some clinical trials on autism and depression and anxiety and traumatic brain injury and many diseases that are related to brain function. And that's probably like because, for example, in Harvard University, they published recently a pilot trial which showed very good results for the treatment of depression. And it's a very common health problem. And so far, the antidepressants haven't been that effective. So I guess one indication that I'm very interested of here is depression, because if the upcoming studies show beneficial results, that's gonna affect many people, because red light therapy would be a treatment that is very easy to give to people. You don't need a drug, you need just a proper light source. And then there is some very promising study on some diseases or related to mouth. For example, this aphthous stomatitis or cancer treatment related mouth inflammation. Then there is one, there are many researchers that are very interested in the effects of red light on the eyes, because many old people get this age-related macular degeneration, and there are some pilot studies that show that red light could improve visual acuity, contrast sensitivity, and also to decrease the harmful pigment called drusen that you find in the eyes of old people with this age-related macular degeneration. So right now there is one ongoing study that is gonna address the possible beneficial effects of red light on eye function. But basically there are a lot of potential indications that could possibly be treated with photobiomodulation. And if we look at the existing human evidence, even if we look only at the systematic reviews, there are like a lot of positive results for very different issues, like many painful conditions like neck pain or back pain, or some other diseases like hair loss. And in Brazil, they also study it a lot for exercise performance, because so far there have been many studies showing that red light could improve exercise performance and maybe also make the recovery from exercise faster.
We noticed that many of the studies on red light therapy are done in Brazil. Why do you think this is?
First, Brazil is a very large country, so I guess they contribute to many different topics. And I don't really know, I don't have any good reasons for that. I often ask other researchers what they think about Brazil, because it's a country that I don't know much about, and they kind of publish a lot of interesting papers. I have had this idea that maybe Brazil could be like a low income country that produces low quality research, but basically almost all of the researchers that I have asked this question, they have that the research coming from Brazil is good quality and that they respect the country. So at least nowadays I have a good, I view the country in a very positive way. And I was also going to say that Brazil, if we look at the photobiomodulation research coming from Brazil, the research is coming from very many different cities and states within that country, or are they called provinces? Like the whole country of Brazil, it's kind of separated to many different parts, and they have a lot of different cities that publish research about photobiomodulation. So I guess within that country, the interest into photobiomodulation has spread very widely.
What do you think about the biphasic dose response? What do you think causes it, and is it always applicable?
There are hundreds of animal studies and cell culture studies that show this biphasic dose response. So if you give very high dose, then you see no benefits. And if you look at some review articles that try to address this effect, they often say that it could be related to excessive production of reactive oxygen species within the mitochondria. And that's what most of the researchers tend to think. And some other researchers also claim that the benefits of red light therapy, it could be a hormetic response. Like this view implies that red light is a mild stressor to the cell, and after the exposure, the cell kind of has this adaptive response that makes it stronger. And in this field of hormesis research, they often claim that like a small amount of this stressor is beneficial for the cell, but too much is not beneficial anymore. And exercise is one example of hormesis. If you do a little bit of sports, it can be very healthy, but if you overdo it, it can be harmful, because then you have too much of the stress and your body is not able to adapt to its effects.
What do you think about the research showing systemic effects? And do you think this is an important avenue for red light research to explore more in the future?
Yeah, so far there have been maybe 20 or 30 papers that have reported some kind of systemic effects, meaning that you can irradiate one body part, but then the beneficial effect also appears in some other body part. For example, there is some research in sheep that if you induce a heart attack, then you can get some protective effects by irradiating their legs. And there is also some evidence from rodents that you can get some protection against Parkinson's disease if you irradiate their bodies. But in those studies, they protected the head from the light rays, so they didn't receive any light to the head, but they irradiated only the body, but still they had these protective effects. And I've been very interested in this perspective because, for example, sunlight has been associated with decreased mortality and less multiple sclerosis, and there are a lot of interesting associations between sunlight exposure and better health. In the past, these associations were often explained by vitamin D exposure, but nowadays we have a lot of data showing that vitamin D is probably not that beneficial, because so many randomized trials have failed to show the actual benefits. But if sunlight is associated with better health, I think that one possible explanation could be the red light and near infrared that you receive, and it could somehow improve the function of your whole body. And the animal studies showing beneficial systemic effects kind of support this view that you can get some kind of beneficial effects to the whole body when you get some irradiation, some red light on your skin. I think there was even one animal study showing that if you irradiate the ears of the rabbits, then you have less calcification of the aorta, like the largest artery in the body.
There's research showing effects even when cytochrome C oxidase is knocked out. Do you think that red and near-infrared light exert their effects through other mechanisms, and if so, which?
Yeah, most often when you ask somebody how does this red light therapy have its beneficial effects, the most common answer is that it has beneficial mitochondrial effects by activating mitochondrial cytochrome C oxidase, and that could lead to many effects within the cell. For example, the increased expression of some genes that are related to mitochondrial function and other important cell functions. But then very lately, a research group in Brazil published a cell culture study showing that you can get some benefits also even in cells that do not have cytochrome C oxidase. So it's very likely that there are some other mechanisms in play as well. And there are some scientific review articles that list all of the different possible photoacceptors that could mediate those beneficial effects. That includes, like, for example, some calcium channels within the cell. And one group of photoacceptors that has this, that some researchers that I do respect, that they find probably relevant, is those compounds that have bound some nitric oxide. So when you irradiate those compounds, they release nitric oxide, and nitric oxide also has some effects on the cell. They are a little bit difficult to characterize. In some contexts, nitric oxide can be harmful and it can decrease the cellular metabolism. But then, for example, if you ask circulation researchers, then they often say that nitric oxide is very important for blood circulation and artery function. And I guess some researchers have this idea that when you have this light irradiation and you release some nitric oxide, it could improve the blood circulation in that part of the body. So that's one possible explanation. But there are some pretty good literature reviews that describe some other mechanisms as well. For example, Mike Hamblin published this review article with a Brazilian guy called Lucas de Freitas, and they published quite a good review article on various mechanisms in 3 years ago, in 2016.
Do you think that red light exerts some or perhaps all of its effects through hormetic mechanisms?
I guess so far that's mostly speculation, this whole hormetic point of view. So far, I guess there is lack of cell level research on PBM, so we need maybe some hormesis researchers to kind of make some light research and maybe see if some pathways related to hormetic mechanisms are upregulated from red light, and only after that we can kind of have better speculations about these hormetic mechanisms.
What do you think are some of the studies that show histological damage? Do you think this may be indicative of hormesis and ultimately a net positive effect?
I have this, in this database that I have, including like 4,000 studies on red light therapy, I have a category called safety of PBM, and I've been trying to look at I've been trying to find studies showing harms from red light, and basically very few studies show any kind of injury from red light therapy, and maybe there are just like a couple studies showing some actual harms. And for example, there was like this one study where they irradiated testicles in, I guess it was in rodents, and it showed some harmful effects. And I don't really have a clear opinion on what to think about that. I haven't looked very carefully at those studies. In some cases, a mild injury could lead to an adaptive response, but yeah, I don't know what to say about that specific case, if you are referring to the same single study that I referred to. There are also like some studies where they have caused injurious effects with very high doses of light. For example, there was one rat study where they irradiated the ears, and they used like more than 7,000 joules. So that's quite logical. If you use extremely high doses, that could probably cause some kind of not so beneficial effects, even harmful ones.
Now, what are some of the claims you frequently see made about red light therapy that are not backed by good evidence?
I think that many companies are trying to market their own product as better than the other products, and the marketing claims are quite diverse. There is this Swedish dentist Jan Tuner who has like written about that in his book. But basically, like for example, there are many companies that are selling a laser product and claiming that there is something special about lasers as light sources. But nowadays the research seems to suggest that like LEDs are not worse than lasers for photobiomodulation. And some companies are claiming that they are selling a pulsed light source, but there is very contradictory research on pulsing, and I think it's not very relevant whether the light is pulsed or not. And within the laser marketing field, some companies are trying to sell their super pulsed lasers, claiming that there is something super about that, but I think there is no sufficient evidence for that as well. So basically, at least many marketing claims should be investigated carefully, and I think many of them are not very plausible.
Do you use red light yourself, Vlad? And if so, what kind of lights do you use?
Yeah, quite recently I got myself a LED panel that is pretty similar to the smallest one that you are selling, the CytoLED 1 product. And I use it basically like for 1 or 2 minutes a couple times per week. I'm not that super regular with it. I'm pretty young and I don't have any diseases, so I think that there is like no much reason to be super super strict about these health improving interventions. But basically when I do the light treatment, it feels pretty somehow good. It could be placebo, but that's kind of the reason why I keep doing it.
What are you working on in the database right now? And what are your general plans for the future?
Right now, my database is mostly complete. That in the past, there was constantly this situation that it lacked many studies that had been published in the past, but now it has almost everything in it. So basically the main thing that I'm doing is just keep adding the new studies that are being published. And also there is one Japanese journal called Laser Therapy, and I should also add some articles that were published in that journal like 20 years ago. That's still on my to-do list. But basically, I'm gonna have a very intensive year at the university, so I'm gonna just keep doing this basic housekeeping stuff. I mean, adding new studies, and I have 1 or 2 review articles on my to-do list that I'm gonna probably finish before the winter. But right now I'm not very active not doing these photobiomodulation related things very actively. I think I will think about some other, like some new projects maybe next summer when I will have hopefully much more time.
Well, thanks very much for talking to us, Vlad. Do you have any final words to sign off with?
Yeah, thank you. It was nice talking to you. I don't really have anything special to say. I can be contacted by internet if somebody has something more detailed to ask. And basically, I wish the best of luck for your company. I guess it's a nice thing that you have decided to start working on PBM, since I know you from like many years before.
Well, that brings us to the end of our first episode. We hope you enjoyed the interview. Presumably you did if you made it this far. Once again, we have our social media and website links in the description. CytoLED.com. Come and talk to us if you have any questions. We're more than happy to talk. Don't be shy. Make sure you subscribe so you don't miss future videos and updates about CytoLED, and we'll see you in the next one.